is cute.
Yeah. So
Yeah.
it's the only one in existence. All right, I'm gonna go live,
Okay.
and I'll let you know when we're actually live. All right, in theory, we should be live. I just assume that YouTube works now. How could it not work? Hey, everyone! Welcome to the interview portion of Open Space this week. We're December 11th. 2020. And this week, I'm pleased to be joined by a good friend, a longtime collaborator, and fellow Canadian, Elizabeth Howell, PhD, Dr. Elizabeth Howell.
Yeah, like a Doctor Who, right? I'm going across the universe. I've got my little phone booth. I know exactly how to do these things. So
Is that what you do when people ask you what kind of doctor are you? You just say, I'm the doctor?
I'm the doctor.
The
I'm the
doctor.
doctor. Come on.
Yeah, absolutely.
Yeah.
Cool. So for people who don't know who you are, why don't you give us a brief introduction?
For sure. So I saw the movie Apollo 13 when I was 13 years old, and I wanted to be an astronaut. And I eventually transmogrified, to use a Calvin and Hobbes term, into a space journalist. And so basically, what I do every day is I write stories, I write books. I also do communications teaching for students to teach them the basics. And the PhD is in space studies at the University of North Dakota. So good people over there, too, if you want some ideas about how to break in.
So I don't even mention your name, Elizabeth Howell. Yeah, I did, Dr. Elizabeth Howell, right? So wait a second. So that is the PhD, is the PhD in space studies. So what does a doctor of space studies do?
Well, a doctor of space studies can do just about anything they're set to do. Basically, what you do is you define a bit of research that is of interest to yourself, and then you go forward into your career and figure it out. And so, in my case, I was interested in how astronauts communicate in isolated situations. And funny enough, that ended up being far more relevant research than I ever imagined, because what are we doing this year?
Yeah,
Communicating in isolated
communicating. Yeah.
but what it ended up doing, though, was it got me into the mindset of how an astronaut thinks and performs and how they do their work and how they interact with others from a distance, which helped me in writing my book and also, in fact, working with some astronauts over the years. And so it was a fun journey, and it still helps me today.
Now, for the rest of this episode, I think we're going to shift to our native Canadian accents. So, if you have trouble understanding us, that's because we're speaking in Canadianese. But yeah, so you are, I think one of the other big space journalists who happens to come from Canada. And it's funny because we spend all our lives focusing on European research and Japanese research and Chinese research and, of course, American research. But Canada has a space industry.
A big space industry, exactly. And so I think that what's really cool about the Canadian space industry is we realize that we don't have the economies of scale like you would see in Europe or the United States. We just don't have the population. And so we said, hey, we want to participate, but we want to do it in a more sustainable way. And so traditionally what that means is we're sharing the vehicles, so the rockets and the space shuttles and the other types of spaceships, all that infrastructure we share with international people. And then we make really cool contributions in high performance fields, which tend to be sort of along medicine and robotics and lately artificial intelligence. And so that means we still provide a lot of high value, but we're able to share the costs and have kind of joint space programs with other people. So it's a lot of fun.
And you recently wrote a book, Canadarm and Collaboration, which I'm jealous of the people, the Canadian heroes that you got a chance to talk to in writing the book. So can you talk about the book?
For sure. So the book was basically a lifelong journey. It's a book that I've been wanting to write and also to read, in a sense, ever since I was a kid. And what I wanted to do was to show not only the cool things astronauts do up in space, which is a tiny fraction of their career, but also all the other things that they're participating in throughout their career. Because a lot of the time that they spend as astronauts is spent doing training, helping with spacecraft systems, performing simulations. And I felt it was really important to show people that being an astronaut is not only about the space stuff, it's also about all the teamwork and all the collaboration, like the title says. And especially in the case of Canada, that's meant that we've had to think international collaboration. For example, one name you might recognize is Chris Hadfield. Among all the astronauts, you might
Yeah,
have heard that
I've
name.
heard of him. Yeah.
Yeah, maybe you heard of him. So back when no one would have had heard of him and he was just a junior astronaut, he took the risk and also the opportunity of collaborating with the new Russian Federation for the Mir space station. So he actually went out and he learned Russian. And this is a guy who was a fighter pilot in his past life and had been trained to fight down the Soviet Union, right? But he had to make that mind shift along with the rest of the world, that Russia was now a new country. And that opened up all kinds of opportunities because he got to visit the Mir space station, the Soviet slash Mir, Russian Mir space station. And that also sort of led to his long path to being the tweeting commander of the International Space Station some years later.
Right. And so when Hadfield flew on Mir, he didn't do that through NASA the way other NASA astronauts had later on. I know there was like an English, was it Tim Peaks was on?
Yes, Tim Peake went through, yeah.
That's right. Yeah, yeah. And so I guess the Russians were allowing various, and I think they allowed an American astronaut or two on as well, but they were allowing people from other countries to spend time on the Mir space station. And it really was the precursor. That whole process was the precursor to what happened with the International Space Station.
Exactly. So the way that Canada participates is we have, it was astronaut Mark Garneau, our very first astronaut in space, who had a wonderful expression, I think, that I used in the book, and it's called pay to play. And so basically what we do is we, as Canadians, provide robotic hardware. So that was the Canadarm, then the Canadarm 2 and Dexter, and later on Canadarm 3. So we give this great hardware. And because it provides such value to the space program, we can grab satellites, we can help with spacewalks, we can do all kinds of cool things, right? Then NASA provides astronaut seats. And the astronaut seats are based on a percentage of funding. And so in the case of the space station, for example, Canada provides about 2.3%. And so that means that we get 2.3% of experiment time and astronaut time up there. Back in the 90s, though, because there were so many shuttle flights that were flying, it was an insane time, right? Remember that, Fraser?
Yeah.
Really cool time. There were shuttles going up 5, 6 times a year sometimes. And so what Canada did was it managed to broker a collaboration with the United States to go once a year. There were so many astronauts going, we could just get up there as often as we could, right? And that's when Chris got this really cool opportunity to head up there. And it just was a really rich opportunity, obviously, because it helped us learn about another space program besides NASA's, which we were participating in. And it also allowed us to kind of expand our horizons and to begin to think about other ways that we could start participating. And look where that brought us, right?
Yeah. In the U.S., I think people are very familiar with the big companies that handle a lot of the Boeings, the Lockheed Martins. What are the companies in Canada that are providing the hardware, the engineering for the various missions that fly to space?
The really big elephant in the room is MDA. So MDA happens to be the robotics company that does all of the Canadarm work and all of the Dexter work.
That's McDonald, Detweiler and Associates, right?
That's right, exactly. Now they tend to have dropped that McDonald Detweiler Associates. They just call themselves MDA now, but that's historically their name. Previously, it was Spar Aerospace. It was Spar that actually built the Canadarm, which was built out of government technology before that, our National Research Council, not the US Council, the Canadian Council, just to confuse you even more. However, what's really interesting is we have this big giant MDA, but then we also have a constellation, if I can use a space term, of other really cool little space companies that are constantly contributing little bits of technology. And one of my favorites is, I don't think they're called this anymore, but ComDev, which is based out of a smaller town in Ontario. They provide satellite hardware, and they basically provide stuff, just all the stuff that makes a satellite run. And they have done into the high 90 percentile of satellites that have ever flown. So just little components, we're talking switches, things like that.
Right.
And that's a really great way to build a recurring business revenue stream, right? Because they're able to provide something that can be put up over and over and over again. And that's why I love talking to the companies. They're always very creative about doing a lot without spending all that much money on it, right?
Right, and it comes back to that idea of collaboration, working your way into the product line of all of those different satellites. It's funny, people don't. I've never mentioned this before anywhere, I think, but I actually, back in the late 1990s, worked for a web development agency out of Vancouver. And that's how I sort of got my start in doing website development. People know that, but one of our clients was RadarSat. So
there you go.
Yeah, so we actually built and managed RadarSat's website back in the late 1990s, and they're still going strong.
Exactly, and that's the other big branch that MDA is known for. It's not only known for all the robotics, but also the Earth observation line. And that line has just kept on going. There's now a RadarSat-3, which is actually several satellites that are doing the same things, but better, that RadarSat was doing in the 90s. And so another good thing about Canada is when we find a technology, we stick to it. We just keep on going. Like I'm sure that by the time that you and I retire, there's going to be a Canadarm 7, right?
Yeah,
You know?
yeah,
Yeah,
right.
yeah.
Now you mentioned. So let's focus on some of these technologies. So first, I'd like to talk about the ARM technology. So what is sort of the genesis of this? How did we get into the ARM game?
So it's a really cute story about this guy in the 1940s, I think, and 50s, who was sort of rolling a cigarette back when people smoked cigarettes more often than they do today. And he realized that you might be able to do the same thing in space to extend antennas. Because the problem in space is that things stick, and you don't really have lubricant that's very easily works in space because liquids don't really work in space. And so essentially what he thought was maybe if I can get this unfurling situation going on some kind of metal, maybe I can get an antenna that extends. And that antenna ended up flying on our first satellite, which was Alouette. And it was so useful, this particular type of antenna, which is called STEM. I can't remember the acronym offhand, but it was so useful. It flew on a number of satellites, and it also actually flew on the Apollo missions to the moon. It was what helped the landing legs come out, which is also Canadian technology.
Wow,
So yeah, so the cool thing is people know that, the Americans landed on the moon, but technically the Canadian feet and legs were the first to get there. Technically. So
that's
technically
interesting.
yes,
Yeah.
exactly.
So,
Yeah.
I mean, just to interrupt you, that this idea of like different kinds of metals, I mean, they actually cold weld in space. Like they will,
Exactly.
if you, and so it's a really tricky problem. If you have two different metals side by side, they're going to try to stick to each other if they have different expansive levels. Like steel and aluminum are going to join until their temperatures come down to a point that they'll release.
Exactly.
And
So
as you,
Canadarm wasn't, sorry, go on.
Oh, I was going to say, and then as you said, this idea of lubricants that you can't have, the pressures don't work, things will bleed off, gasify,
Exactly.
that you just
Yeah.
can't have lubrication in the same way, and it's a really tricky
You
problem.
just can't have lubrication in the same way. And I think it's really cool that we knew this when we hadn't even flown a single person in space at the time. We hadn't even flown a satellite, but we were already starting to think about the problem. We just knew from looking at the upper atmosphere, there wasn't a lot of, atmosphere to play with, and it was going to get even worse as we went further and further up. So Canadarm was built on somewhat the same technology. It's not quite an unfurling thing, but it's basically the same kind of idea. The other unique thing about the first generation of Canadarm was something called an end effector, which is basically a little set of wires. I'm trying to sort of show with my hand here.
Yeah.
It's like a set of wires. And what it can do is it can grasp onto satellites. And it's very flexible, right? It can expand, it can retract. And again, no lubrication is required because all it is wires going in and out, in and out. And so what they did was they managed to grab onto satellites that weren't quite designed for it even, or other situations. And that ended up being super helpful because the first generation of Canadarm helped with spacewalking. It also helped with the Hubble Space Telescope with doing all those repairs and upgrade missions that were happening over the years. And because it was so successful, then NASA basically went back to Canada. So I guess I should go back into the timeline. So Canadarm flew on the second shuttle mission ever. They basically had not even finished testing the space shuttle yet, and they felt we really should have this Canadarm technology because what it would do is it wouldn't have the space shuttle as little self-enclosed spacecraft anymore. It could begin to interact with the environment. And that was really important to NASA because they wanted to sort of frame it as a big transport vehicle. It could bring satellites up, it could bring satellites back down potentially, and other types of things. And eventually it constructed the International Space Station, which was in their heads, but not quite out yet at that time. So anyway, Canadarm flew on the second space shuttle mission and really impressed NASA. They had only a limited amount of time to conduct the test because there were some unrelated problems on the space shuttle. It was overheating, and it performed flawlessly. And Canada was invited very quickly afterwards to form an astronaut program. And it all happened very quickly because we had that Canadarm fly up in 81. And then Marc Garneau and the rest of the astronauts, the other 5, were selected in 1983, the same year as the Right Stuff, by the way. So they were called, there's a lot of allusions to the Right Stuff at that time. And then Garneau flew in 84. And it was a bit of a shock to everybody how quickly it happened because he wasn't even training in Houston at the time. He was still in Ottawa. That was where the space program was based. So Ottawa, Canada, which is a very cold, northern, snowy place where I live. We're going to get a big ice storm this weekend. And that's where he was living, nowhere near NASA. And then he was selected to go on this mission, and he goes down, and it's huge culture shock. All these American astronauts are going, but I've been sitting here since Apollo, and this guy gets to go first. Like, what's going on here, right? And so there were a few kinks that had to
Yeah.
be worked out in international partnership, but it ended up working out, obviously, because it's been 30 plus years and we're fine.
Yeah. 2%
Yeah,
all of the missions. That's what we get. So,
yeah.
so the Canadarm, the first Canadarm flew with the space shuttle and went way beyond this idea of being able to just grab satellites. I mean, they were, as you said, they used it to construct the space station, but it was even so precise that they would use it to hold astronauts to be able to work on things like the Hubble Space Telescope, so they could stand on it.
Super, super cool, right? When you think about it. And what we have here in Canada still is highly trained roboticists that train all the astronauts on how to work the hardware. So they literally come to the Montreal area to this day, and they have training on how to do that. And I think that a lot of people don't know that we have training facilities for astronauts in Canada, but it's true, we do. So that was something that was really gratifying. And when they were building the International Space Station, which took basically the better part of 2 decades, and that's not even including all the funding and planning phases before that, but they said, this arm is so useful, we want to have a better arm. And this better arm, called Canadarm2, as it turned out, is going to be on the critical path for constructing the space station. So in other words, the space station is going to need this arm to be finished. There's no other way. And it actually was Hatfield who helped put that arm out, and Canada was kind of celebrated that day, actually. They did the national anthem for our country from Houston, which I think was the first time that pretty much any national anthem was played in space. It was pretty cool. And Scott Parazynski, who was the other astronaut out there at the time helping Hatfield, was named an honorary Canadian. This is back in 2001. So it was a pretty cool moment. I was a teenager at the time, watching the whole thing on dial-up. So it was, 8 hours of video. Yeah. But it was still really cool. I could hear the audio. I just couldn't see the video very clearly. It was very blurry. But that was a very proud moment for Canada right there.
Yeah. And then they built a special version of it for the International Space Station. So once it was built, it got its own version of this.
Exactly. And one of the great things about Canadarm2 was originally, as I mentioned, it was supposed to just build the space station, help with spacewalks, but it actually helped in a couple of crucial ways that we weren't anticipating. So one of them was, I'm not sure if folks remember, but there was this moment back in 2009, I think it was, and Scott Parazynski, again, he was up in space. He and his crew delivered this solar panel, and the solar panel was supposed to be unfurled, and so it could collect sun's rays, obviously, right? And it got stuck. And so the shuttle crew is there, the space station crew is there, and they're looking outside and they're going, that doesn't look good. It's all tangled up out there. So they're taking pictures, they're sending it back to NASA. And eventually it was determined that, they can fix that solar panel, but we're going to have to put Scott Parazynski not only on the end of Canadarm2, but basically what they had done was they adapted one of the Canadarms into a big expander sort of a thing, like a big extra arm. So we're going to put him on the end of this extra arm too, and he's going to be dangling, several dozen feet away from the main living quarters and working to fix the solar panel. And so they basically MacGyvered this wonderful solution that involved wires and a special hockey stick tool. And they made sure that he was super, super safe from the powered solar panel. So
right. Yeah.
And so they had all this rubber and grounding materials, and it worked. Like, it was a crazy, crazy spacewalk, one of the best ones ever, I think, because it just was ingenuity, NASA style. And Canadarm and Canadarm2 both ended up playing a starring role. The other way that Canadarm2 ended up being unexpectedly useful was in that period where cargo ships were coming up to the space station and there were no new docking ports to accommodate them, because that takes time and effort and also a big spaceship to carry it. And Space Shuttle was retired. And so NASA and the international partners thought, hey, why don't we just have Canadarm2 go and grab these spacecraft? And it was kind of a crazy idea at the time. Nobody had really anticipated it, but there's never been a major issue basically over all the years. It's just been working great with the astronauts working in the cupola, that 360-degree window. They look outside, and then just after they were trained that way, they look out there and they grab their spacecraft and they bring them back in. They reel them in like a fisher person.
Yeah. So, I think now a lot of the Cargo Dragon and the Crew Dragon are docking. If the port is available, they'll dock at the port. But they're also shuttling and shifting around the various docked spacecraft around to the various ports as needed to leave the main docking port open for the next spacecraft that's going to arrive. And so now, but the cool thing about the one that's on the space station is that it can crawl around the space station like an inchworm.
It can, yeah. So both ends can be actually manipulated so that it crawls along. And then what also can help out is this hand, which is called Dexter, and it's basically a robotic tool. It's the best way I could sort of describe it. And so it can do little refueling operations and moving big things around the space station. And this really helps with the preparations for spacewalks and also for maintenance, because the less maintenance you have your crews doing, the more science they can perform. And so over the years, NASA has been outsourcing, in a sense, all this maintenance on the exterior of the space station, moving things, fixing things, taking a look at leaks, that type of stuff, to the control center in Montreal. And so there are Canadian roboticists that work nearly every day now with Dexter and associated robotic technology, trying to sort of help out with the operations of the space station. So that's another really cool way that robotics just help our everyday life in space, all the way from Canada.
Yeah, and I mean, a big part of it is just scanning the exterior of the space station very carefully to make sure that there aren't any, to check the wear and tear, the maintenance on various things. But I love this idea that with the Canadarm, with it essentially able to kind of inchworm, it'll lock on with one end, grab another end, kind of flip itself end over end, and just move itself around. And then it has this additional, as you say, this Dexter, this kind of hand that it can pull out and then use with all kinds of various tools that are available on it, camera, various wrenches, and so on. And so it can make its way around the entire station wherever it's needed. There's these grabbing points that it can be used.
Yeah.
And it's been used for some pretty interesting work and science as well. So then what does the future hold? I mean, we know there's the Deep Space Gateway. What are the future plans for this?
Well, first of all, let's mention that the International Space Station might even go further in terms of its timeline. So it's supposed to be going until 2024, but NASA, the Europeans, Russia, Canada, all the space station partners are trying to push it even further. So maybe to 2028 or 2030. The parts are rated for that. It's just trying to get the funding in place. So we might see Canadarm2 and Dexter being used for the better part of another decade. But what we're doing now is we're shifting into the moon. We're trying to get NASA astronauts and eventually other astronauts onto the surface, participating in lunar operations. And that is going to require, if we're trying to think sustainably, an infrastructure. You don't really want the Apollo style anymore, which it was super cool for its day. But the problem with the Apollo style was that they basically threw all the infrastructure away after every mission. They would just land on the surface, they would take off again, and then there was nothing they could reuse, no reason for them to go back. So now what we're trying to think is maybe we can have some kind of an orbiting base. So that would be the gateway. And then on the ground, we could also have a base maybe at the South Pole or some other place, and then grab some of the water, ice, and other resources that are nearby, do some mining, try and make it a little habitat or a little settlement, as opposed to just leaving and coming back and not really having any reason to go back. So Canadarm3's role in this is going to be being on this Gateway space station and helping with all of the repairs and maintenance, even when astronauts aren't there. And so it will be equipped with a measure of artificial intelligence so it can go and find things on its own. So it can look for leaks or micrometeorites or other kinds of problems and relay that back to Earth. And then maybe it can do some of the more simple repairs by itself, depending on how smart it is. I'm still waiting to hear about all the things it's going to be able to do, but that's kind of the idea, that it's going to be able to help us out without necessarily getting the astronauts involved.
It is interesting. I mean, just to rabbit hole on how Artemis could be such an improvement over the existing, or how the Apollo missions worked, because in theory, say you're going to launch on a Blue Origin New Glenn rocket. The first stage of that is reusable. Maybe the upper stage has to go, but the capsule is reusable. It's using either an Orion capsule or an upscaled Crew Dragon capsule. It makes its way up to the Deep Space Gateway. The lunar lander and ascent transfer module have already been delivered in a separate mission. So really all we've lost so far is like an upper stage or two. And then the transfer module delivers the descent vehicle to the lunar surface, and then it's able to return back to the Deep Space Gateway and get refueled. The lander lands on the moon at the base. They refuel the ascent vehicle,
With the stuff on the moon, ideally, right? You could
Yeah,
probably
local stuff on the, yeah.
right there, right? Yeah.
And
So
then the
yeah.
space, they spend their time on the moon, and then the spacecraft docks with the gateway again. They get on to their Crew Dragon to return back to Earth, and every part of this, really, it's the fuel. And if Starship comes
Exactly.
online, then suddenly everything is.
Like one thing that I'm thinking about as you're mentioning all this is sort of the old school railroad system. You know, like we had goods that were being shipped across Canada and also to an extent across the United States. And we had to make sure that everything was reusable, you know, the tracks were sort of secure and that we had these cars that could be reused again and again. And it allowed us to ship things at long distance without having to spend all the money to rebuild and rebuild and rebuild. And that's what's so important about deep space exploration. If we can do what's called in situ resource utilization, we can use the stuff in place, plus the reusable vehicle aspect you've just been eloquently speaking about, this could reduce the costs over long periods of time and allow us to basically build an infrastructure that could go even further, right? We could possibly take some of these ideas and maybe in another decade or two or three, head off to Mars using already some of the technology we have in place on the moon.
Yeah, I mean, you just take that same idea and then scale it up.
Yep.
I think that's exactly right. That you get a base on Mars. The base on
Yep.
Mars is producing fuel for an ascent vehicle. Maybe you, instead of having a Martian gateway, you use Phobos or something like that. But then
Exactly.
you're transferring to and from, and at each point, everything is reusable and sustainable, and gives you sort of a safe jumping point from each step. Yeah, I feel like I would be really sad if for time frame purposes they rebuilt the Apollo style, throw everything away, throw away the space launch system, throw away the Orion capsule, throw away the lander module. You take all of that material, and all that you're left with is this tiny little capsule that, Orion, that can't be used again.
Yeah, exactly. And it worked very well for its day. I mean, they had a very specific mandate for Apollo, which is basically land people on the moon and bring them back safely again. That was it.
Yeah.
You know, there wasn't really much more to it. They wanted to keep expanding it, but then the problem they ran into, which they're trying to avoid this time, is there was nothing to build upon. Every mission was almost self-contained. They did have the rocket line, but they had to keep building new rockets because we didn't have reusable rockets back then, right? The spacecraft were not reusable either. Once they came back, they were toast. That was it.
Yeah.
So these days, there's a lot more hope because the technology is obviously 50 years more advanced. And we have better computing technology too. So it just allows for a bit of a more automation, a little bit cheaper, we hope, in the long run. And a little bit easier on the astronauts too. So they don't have to manually look at stars all the time and figure out where they are in space and
Yeah.
they'll get lost, right? Because that's what you're reading about the Apollo astronauts. Well, I was doing these experiments, and then in between, I had to go and check out the star, make sure we were still aligned to Earth, and then go back to my experiments. Like, not anymore, thankfully.
Yeah. Now you
Yeah.
gave me a great segue there, which was, you're talking about better computers. That is another big field, and you mentioned this briefly about this idea of Canadarm 3 having various amounts of artificial intelligence, but a lot of
Exactly.
this is starting to come into robotics, rovers, and so there's
Yeah, so one of the great things about the robotics is this happens for all types of robotics, not just Canadian robotics, obviously. But if you build something to take on a difficult task, you can often repurpose the same technology to do difficult tasks back on Earth. And so they are already taking Canadarm technology and using it for things like surgery and also for mining, which are both very dangerous and very complicated fields. There still are humans involved, obviously. That's why we train surgeons, for example. But what they can do is they can sort of use these to reduce the number of tasks a surgeon takes on if they're doing a surgery, and also just to automate some of the more menial things, I guess would be the way to say it. Not that surgery is menial, but there are some parts that just would be better to give the machine. That way the surgeon can rest and do the more complicated things that they actually require their brain and their training for. And that's what I think is really the magic of the robotics. Like once we actually built them, whether it be an artificial intelligence system or actual physical hardware for space exploration, usually the companies are looking for other lines of business. They don't just want to be doing that. So then they start to repurpose it very quickly, relatively 5 or 10 or 15 years, to applications on Earth that can help.
Mhm.
One of the things in Canada too that we're obsessed with is long distance communications, especially up north. And so again, if we get really good at communicating across long distances in space, we can help people living in remote communities or rural communities, especially indigenous populations.
Yeah, I don't know if you heard. They've been starting to roll out Starlink into some of these
Yeah,
indigenous communities, and
yeah,
and for a lot of these communities, I mean, I think people in the US complain about their internet.
Yes.
But here in Canada, we take this to another level. You have no idea how bad internet is, how bad cell phone. Like, I'll give you an example. I have a cell phone. I pay my
Yeah.
cell phone provider about $80 a month, and I cannot send or receive phone calls from my house.
Exactly. It's
Yeah,
atrocious. Yeah.
it's the worst. And I've gone through all three possible
Mm.
cell phone providers that I can get from my house. None of them can give me the main purpose of my cell phone being able to make phone calls.
Yeah.
My parents have been waiting 25 years for internet, high bandwidth internet, and they live, maybe 30, 40 kilometers away from me. So,
Wow.
and I've got 1 gigabit internet, and they, can struggle to get like maybe 1 megabit at two
Exactly.
megabit
So
at best.
we have a big sparse country, basically. That's the
Yeah.
problem that we have. So if you live in like the, I don't know, 100 miles or so worth of the US border, you're fine. There's a lot of internet down there, but if you go any further north, you're having problems.
Yeah, yeah, yeah. And so
Yeah.
they're saying that they're getting 150 megabit download speeds
Yeah.
in these communities, and it is Starlink
Yeah.
appears to be very expensive, and yes, totally ruining astronomers' skies, but it is also
Indeed.
providing what seems like finally these remote communities are getting acceptable internet, and they're able to kind of just
Exactly. And
join
compared
modern
to
society.
exactly, right. Well, first of all, it brings us into modern society. I mean, imagine if you were living towards the Arctic Circle and you can't even get a decent internet connection. I mean, what would that do for businesses, for education,
Yeah,
medicine, all sorts of applications if you can't even access the 22nd century, from
yeah,
there? The other thing too is that SpaceX, to be fair, is starting to dim its satellites. It's still kind of new, obviously, but we're hoping that over time those Starlinks won't be quite as bright. Although I'm glad to hear the astronomy community is putting so much pressure because we need to keep our skies clear. It's not only an observational thing; it's also a cultural thing. You talk to indigenous populations all over the world, particularly say the Aborigines, and they have culture and stories and rituals that are associated with literally seeing the sky. So if it's blotted out,
yeah.
game over. That's
Yeah,
done.
the
Yeah.
latest research on the I just saw a paper that came out like 2 days ago, and the dark
Okay.
sat, the one
Yeah.
they painted black, is about half the brightness of the regular
Okay.
one. So they're already at like 7.5 magnitude, which makes them, you can't see that with the unaided eye,
Yeah.
right? You need a
Yeah.
telescope.
Yeah.
And the visor sat has its own darkening. So in theory, between the two of them, you're going to get, like, nobody will be able to see Starlinks. The challenge, of course, is for those big observatories like Vera Rubin that are going to see,
Exactly.
they're going to see multiple Starlink passes passing through their observatory, pretty much no matter how well they're able to dim these satellites. So it's still a problem. But so I'd like to talk about, sort of like some of the cutting edge stuff that's happening in artificial intelligence with Canadian robotics is in
Hmm.
rovers. They're building a whole series of lunar and Martian rover concepts in Ottawa
Exactly.
using artificial intelligence. So let's talk about that.
Well, basically, the story starts with the last recession, not the current whatever we're going through right now. We don't even know what to call it yet, but there's a bit of a downturn. But the last recession in 2008 to 2010, the Canadian government gave stimulus funding for rover construction. That was one of the things that they wanted to build as a forward-working thing. So Canada and a bunch of companies and universities got together and created these really cool rover chassis. So once you get the actual rover mechanics all put together, then you can start to think about the brains and also about the payloads, the kind of things that they're going to be doing. So the exciting thing is we already have the hardware in place. It's already been tested in pretty difficult environments on Earth. It's basically set to go. So all we need to do now is kind of lop on the latest advancements in artificial intelligence. And I think a good model to start thinking about this is both the Curiosity and the Perseverance rovers on Mars, right? Because we've been seeing so many changes in the way that even Curiosity has been able to perform its work in the however many years. It's been 8 years, almost 9 years.
Yeah. Oh,
That it's
wow.
been on the surface. Yeah, it's crazy, right?
2012.
2012.
Yeah.
Yeah.
8 years of curiosity. Yeah.
Yeah, exactly. 8 years of Curiosity. So one of the things that it can do, for example, is it can autonomously find the targets that it wants to shoot its laser at to figure out the composition of rocks. It couldn't do that by itself before, but with some software
Yeah.
upgrades, it was able to do that. Perseverance is going to be even more powerful because its electronics are 8 years newer than Curiosity's, right? And then if we're able to take those same ideas and bring them to the moon and to Mars again, with humans working alongside, that's where you start to unlock the potential. Again, the robots do the easier stuff. The humans do more of the specialized, I've got advanced geology training type stuff, whereas the robots carry things or they go and they do the simple experiments. And that's, I think, really the potential right there.
There's a term for this. The term for this actually in chess. I think they call them centaurs, where you've got a human being and it's like a partnership between a human being and a really powerful chess computer, and they find that combination where the chess computer is looking at tens of thousands of moves in all directions and surfacing all of these ideas, and then the human looks at the different strategies and thinks about the longer term strategy and then makes decisions. They're finding that they're unstoppable, that combination can beat any chess computer, can beat any human, that it's because our brains, our puny human brains can't think through all of those various combinations. But the thing that we can do very well is make these strategic decisions. And so it's the same idea. We're entering this like high speed domain of robotic exploration. When you think about the dragonfly that's going to be going to Titan, it's going to be flying around, and the light delay is enormous. So it's got to make decisions on its own. You can't keep it safe that far away, the way they had to micromanage every move from Spirit and Opportunity.
Exactly. And I know, are a great student of science fiction, and this has been talked about for decades and decades. And I think one of the more public aspects of that science fiction stories was Data in Star Trek The Next Generation, because constantly he was on some planetary surface with the crew and he would be asked to do some really difficult calculation. He would just sort of flutter his eyelids and it was done, right? Yeah. So that's what's happening already. It's not being done with humanoids, obviously, but it's already starting to happen. And I can just see it even going further.
Yeah, someone's mentioning in the chat that idea of that robot in Interstellar that sort of travels with them.
Exactly, that's example right there. Yeah.
And so you can kind of imagine future robotic explorers having some plastic pal that's fun to be with, who is helping perform some of those calculations, helping do some of this more complicated things, working in tandem with the humans. So where do you sort of see the bulk of Canadian space engineering happening today?
Well, I think that we're going to do two things. First of all, is we're going to keep building on those niches that I was talking about all throughout our conversation. So we're talking robotics, artificial intelligence, and medicine. Those are sort of the three things that we're really doing. But there's also a movement, funny enough, to start getting us more involved in rocketry. And that's because the technology has changed. So back in the 1950s and 60s and 70s, when this was all just beginning, it was all big space agencies really who were responsible for supplying that hardware. And again, as we talked about, it was all throwaway, right? There was not really much in the way of reusability, except when we got to the shuttle, which was partially reusable. Now we got SpaceX, right? And we got other companies as well. They're looking at making reusable rockets, 3D printed rockets, small rockets that are optimized for sending tiny satellites that wouldn't even have been possible given the computing at the time. But now we have satellites that are tiny, CubeSat sized. They can go into space and do Earth observation over a number of months with basically better resolution than what we saw even 10 years ago or 15 years ago in a bigger satellite. So because the infrastructure is not as expensive, there's now a movement among students and among universities to start thinking very seriously about bringing rocketry and other associated types of technologies into Canada as well. Now, whether we could actually launch from here is an open question. There's regulations. There's also the fact that a lot of the country is cold, not so much where you are, on the West Coast, but here there's snow outside the window. You don't want to be launching in these conditions, although the Russians have done it. So anyway, but it's difficult. There's a lot of extra problems associated with the cold. But all the same, if we could at least start building the stuff, we could ship it further south and then have somebody else launch it. And that might give us even more of a say in how space programs are funded in the future. So instead of 2.3%, maybe it's 10%, right? And then we have more astronauts flying, more experiments, more participation, more Canadians, right?
Yeah. So and they're actually building a launch facility in Nova Scotia, right?
They are. So Nova Scotia, thankfully, is somewhat isolated from the worst of Canadian weather. Not all of it, but quite a bit of it. So it's a relatively balmy coastal area.
Right. And I think, one of the reasons to sort of explain why this actually does make sense is that when you're trying to launch a payload into orbit along the equator, you want to be as close to the equator as you can be, and that's why you've got Cape Canaveral, and
Exactly.
you've got the European Space Agency's launch facility down in South America.
Yeah.
But there are many different very useful orbits, such as a polar orbit, and
Yeah.
in that situation, being near the equator doesn't help you one bit.
No, exactly. And Canada's closer to the pole, clearly, than Cape Canaveral. Polar orbits are really good for Earth observation if you want to be getting the whole planet underneath you. It's also really good for defense missions. And defense is actually a very lucrative stream. It's something we don't talk about a lot in the space community, I know, unless you're in the business side. But they have a lot of really advanced contracts that then end up kind of bleeding down into other types of space business after it becomes declassified. And so that's actually really good as well.
Yeah, yeah. So, I mean, do you know when that facility is going to be able to come online?
They keep kind of delaying it, so I am not quite up to date on it, but I would think it within the next couple of years. Although, who knows, pandemic, right?
Yeah.
Everything kind of, but it's definitely being worked on. And I know that there's a committed group of people that have been very busy on that project. So I'm crossing my fingers. I would love to not have to cross a border to go see a big rocket launch.
Yeah.
It'd be, like just fly out there. It only takes me a couple of hours, whereas most places it takes me a day at least. Kazakhstan was a whole nightmare. I mean, it was fun, to be sure. 3 days.
Yeah.
3 days was the humans go into space, and really cool. Again, I don't mind doing it, but it just took forever. So to go 2 hours would be life changing for a lot of us.
Yeah, yeah, absolutely.
Yeah.
It's funny. People invite me to stuff even in the U.S. and they're all so familiar. For them, it's it's an hour flight. They have some near some hub. They fly out of, I don't know, Houston or whatever, and it takes just a couple of hours to reach almost anywhere in the U.S. But for us, I've spent 24 hours just to get to places in the U.S. because it's like I have to fly from my island to Vancouver, from Vancouver to a hub, from the hub to the location. Yeah, I always set aside, all day at the least.
Exactly. And I'll briefly tell you my favorite shuttle story. So I was there for STS-131 as well as the two previous 130-129. So I flew down, and because of obligations between my work and the way the flights were lining up, I got there at a crazy time, and I couldn't go directly to the launch site because I needed an extra badge. I needed an international badge to access it. And so I had to go and wait basically near a NASA badging site all through the night until it opened up at about, to be fair, the 4 a.m. or 5 a.m. And it was just nuts, right? Because I was out there, there were a bunch of other international journalists out there, and it was because our flights essentially didn't line up so we could get there before the thing closed at 7 or 8 p.m. the night before. And what ended up happening actually is by accident, I was ferried over to the public site instead of the journalist site at Kennedy Space Center. And I needed a police escort to go back because by now the crowds were just insane. So it's the only time in my life, but a really fun experience, the only time I've had a police escort anything. So
we should talk about that for 1 second as well, because I think both of us have experienced this, that we are foreigners. And so so whenever we go to the US, whenever we go to cover anything, we're second class citizens. We are not able to see certain parts, like whenever they do tours of like the Orion capsule anywhere in the vehicle assembly building, we're not allowed to go, even though like all the other 150 journalists that are at the, it's us and the Japanese waiting in the press office while everybody else is going on this big tour.
And I understand why that's happening, obviously, right? But still, it shows that there is a bit of a ways to go in terms of international collaboration. It's improving year by year. I'm seeing changes even in the 20 or so years I've been doing this, but there's still some ways to go.
I would say that, in the very least. And then the same thing, the badging. So we're not allowed to drive on to the press area. So
actually, I was, but only after I was fingerprinted and it was sent to Washington.
Oh, really? Okay, not me.
Yeah. So what they said to me, it was a really fun experience. I was in the badging office, and this was again 4:30 in the morning. None of us are really awake, and she's badging me and she's fingerprinting me, and she said, "Now listen," she said, "if we find anything, we're going to be taking you off that site so fast." And I'm just going, it's 4:30 in the morning. Like, believe me, I just want to get on there and get onto the site and see the shuttle go. Like, don't worry, I'm going to be really good. And also, to be fair to NASA, it's just like any kind of facility. They have security checkpoints all the way along the driving point. And so it was very clear where to go. And if you deviated in any sense, there was somebody right there. It didn't matter if you were Canadian or Japanese or American, there was somebody right there. But yeah, for my very last shuttle flight, I did drive on, but only after I was fingerprinted and it was sent off to some security agency in Washington.
Yeah, and they were great about it. I mean, for sure, and they
Yeah,
were very apologetic about it. But
very, yes.
we had to go to one of the I guess there was like a press credentialing area that was off the off site, and then you
Hmm.
had to wait, and then they had to summon a shuttle driver
Yep.
and to take you to and from this to the
Yep.
press office. And so everybody, again, you would be at the press office, and when you wanted, you had to pack a lunch because there was nowhere
Mhm.
to eat. Because if
Yeah,
you wanted to leave and just go for, like, everyone would be like, okay, who wants to go get some lunch? Yeah, let's go to Cocoa Beach. And they would all hop in their cars and they'd go for lunch. And you'd be like, right? I can't go for lunch. I gotta wait. And then you
definitely.
would, and so you just wouldn't eat all day. And then at the end of the day, whenever you had a break, then you would you would go up to the reception and say, "Could you please order me a shuttle?" And they're like, "Yeah, no problem, no problem." And the bus driver would show up just for you,
Just for you.
just for
Yep.
you, and then
Your
they
own
would take
private
you.
shuttle.
Yep,
Yeah.
yeah, your own private shuttle, and
Yep.
you and the Japanese, and then
Yep.
they would take you to the offsite place, and there's your car, and then you get in your car, and then you go for dinner.
Exactly.
So
Yeah.
you just get this.
Actually, I managed to get through a whole sequence of a Florida trip without a car. The funny thing was, I wasn't even licensed yet, and I was in Florida. Which anybody who's visited Florida know that's hilarious. You need a car, but anyway, I somehow managed to string together taxis and kind friends and NASA and the shuttle to get me back and forth to the launch area to see 129 go. So
Yeah.
it is possible, but not really fun.
Yeah, and who knows
Yeah.
whether this was for Osiris Rex. So that was about maybe 3 years ago. So I don't know how things have changed
Yeah.
or whatever. But
Yeah,
um,
exactly. But I also must say, though, that I've had these really fun opportunities to do tours of the NASA facilities. So they've managed to find ways. It just takes usually a little bit more time. So, for example, one of the really cool things I got to do last year before the pandemic took hold was I went over to NASA's Jet Propulsion Laboratory. Now, I was badged in such a way that I had to be escorted all the time, which is
same.
different than
Yep.
US journalists. However, they had this really cool little rover thing that they were driving around the campus in. It was just fun. You just drop into this rover and then you were taxied off to wherever. So I had this personal driver who was sort of responsible for getting me where I needed to go. And then at the end of the day, they said, guess what? We're going to show you some stuff. And I got to go and see the Perseverance rover, then called
Oh
Mars
wow.
2020, under construction. I couldn't speak. Okay, Fraser, I've been doing this space thing a while, but I still was like that's going to go to Mars, and I
Yeah,
can
yeah, yeah.
right there. And what do you? I don't know. So I got to go see that, and they also brought me into the Deep Space Network facility. So basically, the area where they start to send out the commands, which coincidentally is around the corner from where you see the Mars landing happen. So whenever you see the control room with the Mars landing, it's just around the corner from the Deep Space facility. So they did manage to make these accommodations, and I was so grateful
Yeah.
because these were great stories that I could bring back for another book that I was working on about Mars. And that's what makes a book, right? In a book, you have the space to talk about these experiences, whereas usually in an article, you know how it goes, right? I got this deadline, I got to get this out as fast as I can. And then all this richness bleeds away
Yeah.
simply because you only have 45 minutes to get it together.
Yeah, I mean, I think, we are being good natured about this. And, our experience was that everyone at NASA was wonderful about this policy that they had no control over. And they
Mm-hmm.
did everything they could to
To make it
minimize its
comfortable.
impact and to allow us to do our job as
Yeah.
journalists,
Yeah.
despite being, the foreigners that we are. So I think,
Exactly. It's
yeah,
improved. I know of a journalist who was actually Canadian, female. This is important in a second. Female, and covering the Apollo missions. And there was so much freak out when she was asking about being able to get onto one of the carrier ships for, I think it was the Apollo 17 landing. They didn't know what to do with her. You're like, you're not only Canadian, but you're of the wrong gender. What are you talking about? Women don't go on ships. Thankfully, we wouldn't have these conversations today. So thank you to that person for encouraging me and saying that it is
yeah.
going to get better.
So, we spent most of our time talking about Canada, and this is just, me trying to scratch an itch because, I don't know very much about our history in Canada. So thank you for writing the book. But you have another book that came out, and we talked quite a bit about it on your appearance on the Weekly Space Hangout, and that's about the search for life on Mars. So can
Exactly.
you just briefly talk about that?
For sure. So that was a really fun collaboration between me and a fellow from the United Kingdom. So here we were, two outsiders talking about the NASA space program as well as the European space program. And it was a fun adventure because there we were trying to portray the fact that no work on Mars takes place in isolation. It's not like Viking went there, 40 years ago and then we forgot about all the findings and tried to do something new. What we do is with every mission, we build upon what we found before. And we always keep reanalyzing the data that we had before as well. So for example, Viking, I won't get into all the details because we could do a whole show just about trying to find life with Viking, but they found some ambiguous results. That's basically the best that I can put it. They found some ambiguous results that there might be microbes on Mars, there might not. But then what happened was, as we began to revisit Mars and as we began to really understand how extremophiles, that is microbes that work in extreme environments on Earth work, we found out some interesting things. I think one of my favorite ones was, what was that polar lander on Mars? Because what happened was it actually
like
found
Phoenix?
Phoenix, I think it was.
Right.
That was it. It found some of the chemistry at the pole may help explain what was seen in Viking findings, right? But we would have to do more missions to go and revisit this. And so our argument in the book basically was that there is a likelihood, a very high likelihood, that there is going to be life on Mars, and that if we find the right tools and if we're persistent enough, we're going to get to it. Now, I realize that's the same argument you make for SETI, search for extraterrestrial intelligence. But I think that actually in this case, there's a lot of hope because we actually were talking to the scientists. Every single interview, we asked at the end, what do you think our chances are? And almost all of them felt that there was at least some chance of finding life on Mars, some kind of microbe or something that's simple even, but still exciting, right? Having something better than a sample size of one to understand how life was made in the universe is just incredible.
Yeah. And you talked about this idea of an ambiguous result, and that is the worst result. A null result is way preferable than an ambiguous result. A positive result, great.
Exactly.
5
and I know there's some
sigmas.
Universe Today articles about those results, so maybe you might want to drop a link or two to how it all went down, because it's just a lot to explain. And I can't do it off the top of my head very easily. But essentially what happened was they were running experiments and they couldn't really explain if what they had seen was taken up by microbes or not. There was a lot of discussion, and there still is a lot of discussion over what happened.
So what then, right now, as Perseverance is on its way to Mars, how is Perseverance going to be different than the rovers and attempts to search for life on Mars that have gone before it?
What I think is really interesting about Perseverance and also about the ExoMars mission, Rosalind Franklin, that's going to follow in 2 years, is that they have a better way of analyzing things down to almost the DNA level in some cases, right? So they're able to look for example, in ExoMars, they can look at the chirality of the molecules, whether they're sort of trending to the left or trending to the right. And if it trends into one direction, it tends to be more life-friendly than the other. That's basically sort of one of the more interesting things. Another thing that they can really ferret out is the nature of organic molecules on Mars. We know there are organic molecules, but we don't know if these are life-friendly organic molecules or those that are not. They're basically two sorts, if I can put it very, very simply.
Right. The ones that are poisonous almost in some cases.
Exactly, right? Yeah. Because there are some that you just don't want to be, using very often, but then there are other ones like carbon that you want to be using all the time. And so what they can do is they can look at the nature of these organic molecules. Instead of just saying they're organics, they can actually say these are organics that are used by life forms on Earth. Because we always look for life as we know it. But even if we were to find something that is sort of out of whack with the environment, even if we can't explain it with life on Earth, that could be an argument for life, but they would try and go through all the other reasons beforehand, right? Another thing that really is convincing about life on Mars that we didn't even know about back in Viking is the amount of water that used to be on the planet and that still is locked away at all the poles. We hadn't come across those hematite blueberries, for example, that the Mars exploration rovers found in the 90s and the 2000s. The 2000s. And so that right there, knowing that there's all this water that's locked away on the surface, and lately we found pools underground, how much is still sort of to be determined, but that shows another source. So we might have organic molecules, we might have water, and so it seems the ingredients are kind of coming together. We just need to find something solid.
Now you talked to a bunch of researchers and you kept asking the same question. Do you think it's going to be found? Is there like an experiment or a mission that people are placing most of their hopes on? What is going to be the most likely chance of finding life?
So I'll back up a little bit. We have really cool machines that get to go to Mars and that can ferry a lot of results back to Earth, but they can only bring so much with them. It's like in the example that I had where I was going to Kazakhstan, like how many buses and trains and planes, and it was a logistical nightmare trying to get out there, even though the Canadian Space Agency and the other agencies I was working with were doing their best to help me along. I wanted to bring a minimum of luggage, okay, to make this journey because I knew it was going to be difficult and arduous. We have to think about these same things when we go to other planets because it's far away. There's limited power requirements. There's limited mass. You can only get so much off the ground with the rockets that we're using. So what that means essentially is we can't bring all the experiments with us. And that also means that we may not be able to do as precise investigations of life as we want in situ right there. So the solution, bring it back. Now that's simple to say, hard to execute.
Yeah.
However, the next stage after Perseverance will be caching some of the samples, setting it aside, and then presumably there's going to be some kind of a spacecraft following along. It hasn't quite been funded yet, but they're hoping sort of within the next decade, it's going to happen along, grab the samples, and then sort of through a series of relay racer spacecraft, get it all the way back to Earth. And we'll be very careful. Don't worry, we know about coronavirus and what pandemics do to Earth. So we're going to be very careful with the sample when it returns. But the idea is we'll go into some sort of a very super high sealed lab and be able to analyze these samples to see if there's any kind of signs of microbes or fossils or something that could be good. And in a lab, we don't have to bring all the stuff with us anymore, right?
Yeah.
Bring the sample back and then it's there and we can use all the tools that we need. I mean, they're relatively easy to get something from Switzerland to Houston as opposed to all the way out to Mars, right? So even if we needed another tool, it wouldn't be too difficult.
Yeah, and you could just imagine like how exciting it's been to get that sample return back from Hayabusa. While we're talking, you've got the mission from the Chang'e 5, which is going to be retrieving material from even core samples from the surface of the moon. Imagine a sample pack of Martian various materials that were gathered by Curiosity, by perhaps other, or by Perseverance, maybe by other rovers, all collected together, brought home, and then, with the exact locations where they were found, and then geologists and biologists can look through this to their heart's content.
Exactly. And that's another thing that I should have mentioned earlier when I said that Mars missions build upon each other. It's not just Mars missions, it's all missions that build upon each other. So you can bet when they're looking at sample return situations, they're going to be looking at, for example, the first Hayabusa, which did make it back, but had a lot of trouble on the way, right? And that's how come Hayabusa 2 has been looking so smooth so far. They've learned all the lessons from that one. And so what they'll be doing is they'll be taking all those asteroid sampling missions, moon sampling missions, Chang'e 5, obviously, and trying to think of ways to make the Mars mission as smooth and as engineering problem-free as possible, because it's going to be hard enough. Yep. So you may as well try and use some of the same technology, the same lessons learned, as we call it in the space community, to get that sample back. And it's exciting. It may be soon, maybe within 10 or 15 years, which is basically if your kids in elementary school, they may be actually studying these samples when they get to university, which is really, really cool.
Yeah. And do you think we'll get, I mean, I guess if the answer is yes to life on Mars, when do you think we'll get the answer to that question?
Well, it would have to be as soon as the sample return comes back at the least. And so that would be 2030s, I think, at the earliest.
Yeah.
But we have to remember, too, that a single site on Mars does not constitute the entire planet. We would probably, the odds are, I think that we may have to do more than one mission. But for us to even try it once is a good first step. And then we can kind of take a breath. And the thing is, it's so hard to predict more than about even 5 or 10 years in the space world simply because of funding.
Yeah.
We don't really know where the funding is going to be coming from. But the wild card, the really optimistic wild card, is all these commercial opportunities that you and I have been talking about. It's taking over Earth. And I think that before long, within a generation, even sooner perhaps, we're going to see it start to head out to Mars. And so we may start to see SpaceX or some similar company trying to do these similar things by themselves. And there might actually be a commercial return to it, which would make it more sustainable, which means it happens more often. So all this sort of uncertainty of how's NASA's budget going to be, it may be a less relevant discussion before long. Who knows, right?
Yeah. Well, we've reached the end of our time. I know you've got lots of writing work to get back to. What are you working on right now that people can be looking forward to?
I'm going to be working on a fourth book. We haven't quite got the announcement out yet, but if you do a bit of creative searching, you could probably find it. So anyway, there's a fourth book with me and another co-author. I'm very excited to see that go. And on top of that, I continue my work for the usual places that I write for. And so I know that you're citing them all the time, but I'm
Yep.
usually at space.com and at Forbes, and also this Canadian magazine called Space Q, the letter Q. I'm
Right.
trying to do it backwards here. So just whoever wants me to write about space. And I have to say, I'm so grateful to Fraser because he got me started in the space writing industry. You looked up the number once, right? How many articles I did for Universe Today? It was
Yeah,
like
yeah, yeah. It's in the
yeah,
thousands. Yeah,
it's in the thousands. So
yeah.
basically, Fraser is a great contributor to the ecosystem of growing space writers because so many of my friends have come from working with Fraser. So thanks again for having such a
Hey, no
wonderful
problem.
website and being here for so long. We really appreciate
Yeah,
it.
21 years now doing Universe Today.
Incredible.
Yeah, it's pretty
21
amazing.
years.
Yeah, yeah, yeah,
Yeah.
yeah. Awesome. Well, Elizabeth, always a pleasure to talk to you. I'm so excited to see what you write next. I'll do some creative digging, see if I can figure out what it is.
Yeah. You can figure
Um,
out what it is.
yeah,
Yeah.
absolutely. And when they do find life on Mars, come back and let us know.
I'll definitely come back and let
All
you
right.
know. All right.
All right.
Stay safe, everybody.
All right. Take
Bye.
care. Bye.